Okay, I was listening to DJ Fresh there a second, the song Closer. But anyway, yes, I'm driving my car. I think this is fine because I'm still looking at the road. I'm not looking at the screen. But anyway, I was thinking about a physics topic that has been going through my head a lot every once in a while for some reason. That is, there's just a very interesting coordination between velocity and hardness. And that is that when something has a higher velocity, it has a lower hardness. And my head is going in so many different places. But anyway, I don't know. Hardness is not necessarily the word. Rigidity. There's a correlation between velocity and rigidity. Higher velocity is less rigid. Lower velocity is more rigid. And temperature is also higher velocity. Well, of course, they already know this. I'm not saying anything new, but I'm just kind of trying to connect the dots here a little bit. In a linguistic sense rather than a mathematical sense. See, this is the problem that I think there is with most of physics, the way it's educated, is that they can teach it mathematically, but they cannot teach it linguistically, and it needs to be taught linguistically in order for the math to mean anything. Because if you're doing math that you don't understand, then how are you going to know what math to do? You have to understand so that you can find the math, just like the physicists did in the first place. But anyway, when, say, a bullet passes through everything. So why is that? Well, it's because as the bullet moves, everything turns into liquid in front of it. And sometimes I think people might not understand that quite enough. But, think about it. The metal bends. If you shoot a bullet at a piece of metal and it goes through it, the metal gets hot and bends. And that bending is a liquefaction of the metal. The bullet itself turns to liquid. It splashes. If you shoot a bullet at something that's bulletproof, the bullet will splash. It's a solid object, but it splashed. It's almost like the crystalline structure which held it together originally turns into a quantum indeterminate structure, and the particles start moving in random directions, and they're pressured into biases towards certain directions based on the direction of the pressure. But anytime something bends or breaks, it's turning into a liquid. Now, breaking is an interesting story. That might be more like turning into a gas. But bending, anytime something bends, it has turned into a liquid. And so in order to force it to bend, you apply either heat or pressure. But then you think heat and pressure are kind of the same thing. They are velocity. But of course, a feather moving at 100 miles an hour is not going to be as deadly as a bullet moving at 100 miles an hour. Well, I should say more like a feather moving at 800 miles an hour is not going to be as deadly as a bullet moving at 800 miles an hour, because the bullet has much more mass concentrated into a much smaller area. It's more dense. So it has to do with density as well as velocity, and so therefore we're talking about energy density, kinetic energy density. So the kinetic energy density is equivalent to temperature, and it's also equivalent to state. What is it called? Crystalline state, like solid, liquid, gas. These are all just terms of kinetic energy density. But then we have to ask ourselves, what is a liquid and what is a gas? Well, you could just say, well, they have a higher energy density. Or, it's not really energy density. It's not really energy density that makes something a gas or a liquid or a solid. The energy density can turn it into those things, but what those things are is not merely different levels of energy density. That's not what they are, because the gas is actually much less dense than the solid. But no, like, what is a crystal? What is a solid? What is a gas? What is a liquid? When I look at a liquid, I think I'm seeing a sort of quantum effect. The surface of a pool, the waves of the surface of the pool are a fractal recursion of quantum waves. They happen on the same sinusoidal function. The waves of water are perfect sinusoids. And so when I look at the surface of water, when I look at any liquid, I think that there's a quantum effect being brought out into the macroscopic world. And that quantum effect is both the separation and the interaction of the particles. But it's almost like the particles stop being particles. A liquid, at a macroscopic level, a liquid is not a bunch of particles. A liquid is a continuous field. And so what I think a liquid is a field of the elements which make it up. A liquid is a field of the of the molecules, even of the mixture which makes it up. So perhaps at the lowest scale, quantum indeterminacy, quantum superposition is really just very, very fine mixtures. But we get back into this kinetic energy thing. So kinetic energy can turn something into a liquid. What does that mean? Well, it means that it breaks the crystalline structure. But what does that mean? Well, it means that the molecules start moving fast enough to break out of the electronic wells that they are held together in. So now we have to ask, what are these electronic wells? Based on my understanding from going to college for physics, I know that there is such a thing as three-dimensional harmonics. Just like a guitar string can have harmonics at these different frequencies, something vibrating in 3 dimensions has harmonics in these shapes that surround it. And these are shapes. Okay, so now I bring into another parallel the sonic levitation. I think that there is a clear connection between sonic levitation and chemical bonds. a chemical bond is just a sonic levitation of an electromagnetic vibration in 3 dimensions. When a particle exists, it creates a repeating pattern of wells, of crests and troughs in a 3-dimensional shape surrounding the particle. These crests and troughs are made by the electron orbitals, but also by the distribution of magnetic field and positive electric field coming from the nucleus. Now, it seems like the highest that these sonic levitation are, they're more like electromagnetic levitation. These electromagnetic levitation nodes are limited to the kind of structures that you can get with chemistry. However, chemistry goes all the way into biomolecular structures, such as DNA, which is the most complex chemical in the world. However, you could virtually say that a human being, not virtually, literally, a human being is a chemical. You could say that the entire human race is one chemical. You could say that life, all of life, the entire Gaia of the earth is one chemical. And the bonds are very different. The bond between my white blood cells and my neurons is a very different bond than the harmonic nodes of levitation, which are caused by the electromagnetic fields. So now that's what we have to ask. What are electromagnetic fields? Because there's sonic levitation. Sonic levitation is a vibration of particles which causes, it's a harmonic vibration of particles which causes nodes of no vibration and nodes of antinodes of high vibration. These nodes and antinodes are the same thing as the nodes and antinodes of electromagnetic bonding in a different way, but they are the same thing. So what is vibrating? Now we bring in energy and light. The vibration of light, that E equal to HF, energy equals Planck's constant, which really is just a units converter. So Planck's constant doesn't really mean anything. So every energy corresponds to a frequency. That's why it's a constant anyway. It's just a unit converter between energy and frequency. Basically between joules and seconds. That's what the the Planck's constant represents. So every field has an energy. So every particle, every charge must have a sort of frequency. So there must be a sort of frequency that is, and I don't know about this. I'm kind of just venturing into this idea on my own. I'm thinking that every charge has a frequency. And perhaps one charge can have many different frequencies. Well, yes, the electrons can be in different energy states. And so this is, in a sense, giving the charge many different frequencies. And this is almost certainly how the bonding happens. I'm home. I'm just going to sit in my car and keep talking. So what I'm saying is that there's a frequency associated with the electromagnetic bonding of particles. And then I think there's a much higher frequency in the nuclear bonding of nuclei, and then perhaps an even much higher frequency in the strong nuclear bonding, or wait, is it weak nuclear bonding? I'm not really sure. But the bonding of the quarks together. The quarks are bonded together with a frequency. Perhaps each quark is bonded into existence by a sort of frequency. And like when I look at the 6 quarks, I think of it geometrically, because geometrically the number 6 is very important. In 3 dimensions, there are 6 kinds of rotation. And so perhaps each quark represents a certain kind of geometric rotation or a geometric twisting of some sort. So each quark is a different kind of twisting. However, there are only 2 kinds of quarks which are stable, and there's only 1 kind of quark which is stable on its own. Right? Or maybe neither. Maybe up and down, or neither one is stable by itself. But nucleus, the up and down, neither one is stable by itself. They require each other, so it's like male and female. And then there's the proton and the neutron. I sort of look at it as the proton is the alpha, the neutron is the beta. The neutron can't exist by itself. It decays. But a proton doesn't decay. And that's so special. Now I have to find the connection between particle decay and the vibration of electromagnetic fields. So that would be connecting the weak nuclear force with the electromagnetic force. Well, they already did that, didn't they? So maybe I'm just venturing into that territory. The electro-weak. So they have the electro-weak force. What I think they are is they're just different frequencies. Electromagnetic is a certain bandwidth of this higher dimensional vibration, or perhaps it's not even higher dimensional, but it gosh, I don't know. And it just got very interesting with the proton and the neutron there. I just thought of alpha and beta. The beta kind of copies the alpha, kind of sits there. It doesn't do the same thing as the alpha, but it sits there and it looks like the alpha. The alpha makes the decisions, has the charge. Charge is a bringer of movement. The alpha is the dominant one. The proton is dominant. The proton has this movement to it because it's charged. A neutron isn't going to move because charges have no effect on it. The only thing that can move a neutron is gravity. But gravity is a warping of the 4-dimensional space-time. It is a wake created by the object. So, perhaps every field, electromagnetic, weak, strong, gravity, they're all just wakes of distortion of certain qualities. I don't know, but this is the kind of thing that my mind does every once in a while. There's no. I don't know if I'm ever going to get to the end of it, and if I do, I might find the theory of everything, because I don't know. I don't have a direction here, but I'm just kind of learning and learning from myself as I understand these things. Is there going to ever be any math involved? Well, I don't think so. I kind of hate math, to be honest. But what I kind of want a mathematician to listen to what I'm saying and come up with some math, and maybe we can work together on creating this theory of everything. But I'm not really there yet, even with words. But what I do know is that there is something to what I'm saying. There is some sort of connection between sonic levitation and electromagnetic fields and geometry, and the fact that there's only 6 quarks, and what else was there? The liquid thing. The liquid being a quantum effect on the macroscopic scale. All of these things are connected somehow. Oh, and the energy density due to physical state. What do they call that? State of matter. What the crystalline state is basically a repeated it's a repeated wave of nodes which constructively interfere with each other. Each particle in, say, a diamond constructively interferes with the particle next to it in order to create an even stronger bond, or an even stronger node, I should say, an even more distinct node. So in a diamond, the two particles that are sitting next to each other constructively interfere in their harmonic electromagnetic field. So electromagnetic field is just a harmonic distortion of a certain tendency towards movement in time. Oh, God.